Question 5 says the equation of a curve is, let's go back to our black ink. It says y is equal to 3 plus 4x minus x squared. So y is equal to 3 plus 4x minus x squared. And it goes next by asking us, the point 36 lies on the curve. Find the equation of the tangent to the curve at P. So to find the equation of the tangent to the curve, first we need to do is find dy by dx. That's the first thing. Let's find dy by dx. Find dy by dx, and dy by dx is equal to, we differentiate 4x to get 4. We differentiate x squared to get minus 2x. So that's dy by dx. So dy by dx is 4 minus 2x. At the point P, and P is the point 36. At the point 36, we can say that the gradient of the tangent is going to be equal to, we plug in 3 in here to get 4 minus 2 times 3. That will give us the gradient of the tangent, which is equal to 4 minus 6, which is negative 2. That's the gradient of the tangent, negative 2. Now that the gradient of the tangent is negative 2, we can find the equation of the tangent. And so the equation of the tangent is going to be y minus the y value at P, so it's y minus 6, and that's going to be equal to the gradient of the tangent, which is negative 2x into x minus 3. But we can't finish here, so they want it in a particular form. They want it in the form ax plus by. So what we need to do is write it as y minus 6 is equal to negative 2x plus 6. And then we're going to bring the 2x over here to get 2x plus y. And then we subtract 6 from both sides to get 2x plus y minus 12 is equal to 0. Nice and easy. Soft. And that's the answer. That's the equation of the tangent. Nice. Now next it goes to ask us, given that 2x cubed minus 9x squared minus 24 plus 7 is f of x, find all stationary values of f. So we have our f of x, and it says that f of x is 2x cubed minus 9x squared, 2x cubed minus 9x squared minus 24x plus 7. This is f of x. All right. Now, first thing we need to do is we need to find f prime of x. We need to find f prime of x. F prime of x. Now, f prime of x is going to be equal to, bring down the power to get 6x squared minus 2 times 9 is 18x minus 24. That's going to be f prime of x, 6x squared minus 18x minus 24. But at a stationary point, the derivative is equal to 0. So we set the derivative equal to 0. We can then divide through by 6 to get that equation becomes x squared minus 3x minus 4 is equal to 0. So divide through that equation by 6 to get this new equation. We can then factorize it now equal to 0. And that's x, 4 and 1. You say signs are different, but the greater product is negative, minus and plus. And so what we're getting is x is equal to -1, or x is equal to 4. Nice and easy. X is equal to -1, or x is equal to 4. All right, and so we can find the y value when x is -1 by putting in -1 up here. So we get 2 times -1 cubed minus 9 times -1 squared minus 24 times -1 plus 7. And we're getting y is 20. And then we can put in y right here. So put in y as 4, put x as 4 here. So we're going to get 2 times 4 cubed minus 9 times 4 squared minus 24 times 4 plus 7, and that's -105. -105. And so the 2 points are, we can tell them now that the 2 stationary points are -120 and 4 -105. Without even looking at it, I can tell their nature. Think about it. This big negative number, wouldn't that be the lowest point? This one is already the minimum. And 20, that's a big Y value. This must be the maximum. Even without doing it, we know that. But let's just do it for working out case. So we're going to say f double prime of x is going to be equal to f double prime of x. We differentiate 6x squared to get 12x minus 18. That's f double prime of x. We get 12x minus 18. Now since f double prime of x is 12x minus 18, now what we need to find now is f double prime of minus 1. F double prime of minus 1 is going to be equal to 12 times minus 1 minus 18. 12 times minus 1 minus 18 is -30. All right. And then now f double prime of, so -30, as we can see right here, that is less than 0. And so that's the maximum point. When it is less than 0, this is the maximum point. And so we can conclude that -120 is a maximum point. Now, since -120 is a maximum point, now we can go further to find f double prime. Find f double prime of 4. F double prime of 4 is going to be equal to 12 times 4. 12 times 4, which is 48. 48 minus 18, which is 30. And 30 is greater than 0. And so we can conclude that 4, so we can conclude 4, -105 is a minimum stationary point. Nice and easy. Nice. And that's it. So this is part 1 and this is part 2. Part 1, part 2. And that finish off question 5. Now we can go to question 6, which is integration. Question 6. Question 6 is integration, and it asks us to integrate from 2 to 4 x times x squared minus 2. Easy question. So let's boil up this integration. They want us to integrate x times x squared minus 2. X times x squared minus 2 dx. So if we're integrating this now, what are we doing? And we're integrating from 2 to 4. So integrating from 2 to 4, that's going to be equal to the integral from 2 to 4 of x times x squared is x cubed minus 2x. That's what we have, x cubed minus 2x dx. Now, since this is what we have, all we're going to do is add 1 to the power, then divide by the power. So we have x to the 4 over 4 minus, now 2x squared, we're going to add 1 to the power, divide by that power. And remember, we're integrating from 2 to 4. Since we're integrating from 2 to 4, we just plug in 4 first. When you plug in 4, what you're getting is 4 to the 4th power, which I don't know. 4 to the 4th power is 256 divided by 4. This works out to be, I'm getting 64 minus, we'll put in 4 here. 4 squared is 16, so I get 64 minus 16. Subtract 2 to the 4th power. 2 to the 4th power is 2 to the 4th power. That looks like 2 to the 4 is 16. 16 over 4 is 4. Minus, put in 2 here. 2 squared is 4. And so this works out to be 64 minus 16, which is 48. So that's 48. That's the integral. 48 units. Don't want to say units squared, it's not area, I don't know. Units. That's part A. Part B. Part B is asking us to evaluate the integral of 0 to pi by 3. 0 to pi by 3 of 4 cos x plus 2 sin x. 4 cos x plus 2 sin x. Nice and easy. This is what we have. So this works out to be now the integral of 0 to pi by 3 of 4 cos x plus 2 sin x. That works out to be 4 cos x plus 2 sin x. So when we integrate cos, we get sine. So it works out to be 4 sin x. Then when we integrate sine, we get minus cos. So this works out to be minus 2 cos x. And of course, we're integrating from 0 to pi by 3. So all we need to do now is substitute pi by 3. Nice. So let's plug in pi by 3. Plugging in pi by 3, what we're getting is the sine of pi by 3, or sine 60. Sine 60 is root 3 over 2. So this works out to be 4 times the root of 3 divided by 2. Then put in pi by 3 here. The cos of pi by 3 is a half. This works out to be minus 2 times a half, which is 1. Close up that bracket. Subtract. Sine of 0 is 0. And the cos of 0 is 1. So this works out to be minus 2. So all of this works out to be 4 root 3 over 2 is 2 root 3. 2 root 3 minus 1. This works out to be 2 root 3 minus 1. And then minus 2 becomes plus 2. This works out to be 2 root 3 minus 1 plus 2. And so this works out to be 2 root 3 plus 1. Nice and easy. Soft. Well, let's have a look at part C. Part C tells us that the curve passes through the point 2, negative 5, and dy by dx is 6x squared minus 1. It says find the equation of the curve and then find the finite region bounded by the curve and the x-axis and the line x equal 3 and x equal 4. So this is really easy. They tell us dy by dx, they tell us that that's equal to dy by dx, they said that's equal to 6x squared minus 1. So dy by dx is 6x squared minus 1. Now since dy by dx is 6x squared minus 1, then y is going to be equal to the integral of dy by dx. So y is the integral of 6x squared minus 1. That's how we find y. We integrate dy by dx. When we integrate that now, what we're going to get is add 1 to the power 6x cubed divide by the power of 3 minus x plus some constant c. Nice and easy. Now once we do that now, and we have the point 25, so P is the point 2, negative 5. So what does that mean? That means that when y is negative 5, we have negative 5 is going to be equal to, now 6 over 3 is 2, so it's 2 times 2 cubed, minus 2 plus c, all right? And so this is what we have. So let's evaluate c. So evaluating c, what we're going to get is 2 times 2 cubed minus 2, that's 14. So this is 14 plus c. And so if we bring over the 14 over here, it becomes minus 5 minus 14, which is minus 19. So that is c. So hence, we can conclude that y is equal to 2x cubed minus x minus 19. That is y. Nice and easy. Soft. All right, so that's the equation of the curve. All right, nice equation of the curve. Next thing is that it asks us to find the area of the finite region bounded by the lines x equal 3, x being 4, and also the x-axis. So what they're asking us for is to find area of the finite region. The area of the finite region is going to be the integral from x being 3 to 4 of 2x cubed minus x minus 19. That's going to be equal to 2x cubed minus x minus 19. So to find that area, we add 1 to the power. So we get 2x to the 4 divided by the new power of 4 minus x squared over 2 minus 19x. And we integrate that from 3 to 4. So let's work this out now. So all we have to do is plug in 4 first. So plug in 4, and what we're getting is 4 raised to the 4th power divided by, so we have 2 times 4 raised to the 4th power divided by 4. I get 128 right here. So we're getting 128. Now plug in 4 here, we get 4 squared is 16. 16 over 2 is 8, so we get minus 8. Minus 19 times 4 is 76. So we get 76. We'll close up that. Minus, this is where it gets tricky because we put in 3. 3 to the 4th power is 81 times 2 is 162 divided by 4. So that looks like 81 over 2. So I get 81 over 2. Then we'll plug in 3 right here. That doesn't look like 2, so let's fix that. 81 over 2. Then we'll plug in 3 right here. 3 squared is 9. So we'll get 9 over 2. And then we'll plug in 3 right here to get minus 3 times 19. That looks like 3 times 19 is 50, 57, 57. So now we can take their differences. So all of this we just put in the calculator. 128 minus 8 minus 76. That's 44. Minus 81 over 2 minus 9 over 2 minus 57, and I'm getting 65. So I'm getting that area is 65 units square. Nice and easy, 65 units square, soft, soft, with a capital T, nice and too easy, soft.